this first chapter is very small. It only goes through the really kind of the overview of how these slides will work. All these slides are available on Canvas. So this week, I'm going to go through chapters 1 and 2, but feel free to go as far down as you want as you can. I kind of made myself a little schedule here where this week I'll do chapters 1 and 2. Next week I'll do 3 and 4, then 5 and 6, then 7, 8, 9, 10, 11, 12. And that'll give us a week, basically a week off where we can, anybody can catch up on any assignments missed or any questions that they may have. That's kind of what we're looking at for the next 8 or 7 weeks. Is I'm going to do 2 chapters a week, and then that gives us a week break. So VMware is basically what's running behind the scenes when we talk about virtualization in the cloud. It is not the only infrastructure that is used for virtualization at large scale, but it is definitely the top one. Only its second would be like Hyper-V for any local virtualization. Outside of that, you have Zen as another possibility, but it's really the 2 top are VMware and Hyper-V. VMware really does the job well in handling multi operating systems in one, and fault tolerances and all kinds of crazy configurations that you'll see in this course. Like I said, this first little chapter is very short and kind of introduces things that you'll recognize as we go. For example, when it's using different kinds of fonts from a folder versus a command versus something configuration. You'll see these throughout these chapters. There are a number of reference guides that these slides will point to. I would make a note of them because they will be referenced often, and it's good to have bookmarks when you're referencing information, because nobody is asking you to memorize everything off the top of your head, but being able to look up things quickly and find resolutions is definitely something that you should be able to do. There's also a number of sites like blogs and support that you can use as you study, as you practice, that are available to you, that are freely available to you. Like I said, this course does satisfy the training requirement for the VCP certification. It does not get you a voucher, but it does take care of the training portion. So don't just use this as your only resource for preparing for the cert test if you are looking to get VCP Foundation certified. They do have further education that you can do on demand or on your own kind of stuff. You know, if your goal is to get certified, to get this VMware Certified Professional cert, you are definitely on the right track. Like I said, it's a nice short little module. Chapter 2, though, is where we'll spend our time today. Kind of introducing some of the stuff. Some of these things you will have seen in your micro courses. So this should be a lot of review. As I said, all this relies on virtualization technology, something that nobody thought of in the early 2000s, came about in the later 2000s, really took off, and now we use containers. on top of virtualization in the cloud. Pretty crazy. So down to the basics, you have a physical system who is running a virtual instance of itself. It is a virtual machine. It is a complete computer running inside a computer, kind of like the Inception movie. So you have an operating system running, you have VMware tools, which is basically the drivers required for this operating system to work with the quote unquote virtual devices, because the network card is not a real network card. The video card is not a real video card. It's all software, and it needs software in order to communicate and function as though it's connected on a physical system. Now, one of the biggest advantages of virtualization is when you buy a $10,000 server, you can use all the CPU, all the memory, all the hard drive space effectively, rather than installing the operating system on the bare metal and only using a portion of it. I mean, even in our own desktop systems, we don't tend to use 100% of the CPU and memory, nor do we really want to. We'll use it in our games. We'll try to max it out as much as possible. But for everyday computing, we really don't use a lot of power. So can you imagine spending so much money on a piece of hardware and not using its full potential? That's horrible. Using virtual machines, though, we can segment and isolate and do all kinds of stuff to maximize our physical hardware and really use all of it. There are different kinds of virtualization. The one that we're more focused on is using servers to virtualize. So we can create virtual networks, we can create storage, and we can even virtualize desktops within these more powerful servers. This does mean everything is software defined. If you've ever seen the acronym SDN, software defined networks, well, this is software defined everything. Not only are we using software to do things like computing, storage, and network, we're also pooling our resources using software. We're also using catalogs to quickly spin up and spin down stuff. We're using software for fault tolerance and disaster recovery and replication, along with security and management. We're heavily relying on software to maximize the use of our hardware. With vSphere in the VMware world, there's even a cloud function where we can have different cloud infrastructure scattered even around the world and be able to move VMs throughout in order to keep systems on or do backups, or a hot site to a cold site. We can do all those things in the VMware ecosystem. The basic parts of any virtual machine are things like the CPU, the memory, the disk, the network. These are your essential resources that are used by any and all systems. And again, a virtual machine is just an abstraction in software of these things. Now, in a physical infrastructure, the operating system takes control of these hardware devices, these hardware components, and utilizes them. In a virtual architecture, we use a hypervisor, in our case vSphere, to allocate the resources that we have, like our CPU, our memory, our disks, our network, in order to allow multiple operating systems to utilize 100% of what we have, and also be able to manage it all without us micromanaging every little thing. So virtual machines can share the same CPU, they can share memory, they can share the network card and disk space, and be able to work with each other and run simultaneously. From the perspective of the physical device, virtual machines look like programs, like your browser, Discord, Word. You know, the physical CPU is processing these things like it would any other program. The things that are happening within those programs, that's the virtual machine. Because we are working software, we can determine a lot of things that we can't easily do in the physical. For example, if we have a physical system that has 4 CPUs, 4 physical CPU chips, in the virtual realm, we can define and say, virtual machine A, you will only have 1 CPU, whereas virtual machine B will have access to 2. Virtual machine C can have up to 4. You can't necessarily go, I mean, you can, it's just not feasible. It's not easy to get, open up a server and take out CPUs and put them in. That's, you know, that's not as easy. But we can definitely virtually give and take resources on the fly. Same with memory. The physical hardware knows how much we have to fully allocate, and we can use our hypervisor, in our case vSphere, to divvy up the memory for various virtual machines, and be able to do that in a very easy way that doesn't slow us down, but more efficiently uses the resources we have. With networking, any virtual machine can communicate with another virtual machine, and the operating systems within them will create their packets like they would always if it was physical, and send it out the virtual NIC card. Once that packet leaves that operating system, as it would in real life, that packet essentially goes through the CPU of the physical host. It doesn't necessarily have to use the actual NIC in order to get out, unless it is getting out. But if virtual machine A is communicating with virtual machine C, you will never see any packets leave the network. They're talking within each other, so which means this communication is going to happen way faster than it would going from the virtual machine out to the world and back. Virtual machines use threads. Yes, they use threads. In the world of VMware, we can share storage, just like we can share the others. The VM file system, NFS, vSAN, vSphere. We'll talk about these as we go along in the chapters. There's a number of ways that our OSs can share resources. Because virtual machines are nothing more than files, it is very easy to encapsulate them. You know, they are nothing more than just a bunch of files. that just so happen to be able to be processed in a way that they create a virtual instance of a physical computer, which means they are easy to be moved around. That's why you can take a virtual machine from one physical computer and take it to another, and it will still work because it's all software based. As you will see when you do some of the NetLab labs, and as we talk through, there are a number of ways to communicate with our clients. We can either use the web client. There is an add-on that you can add to a browser in order to see, or you can directly connect to a host through vCenter, for example. Generally, you want to connect through the web client. The latest versions of vSphere do have HTML5 support, so you don't need Flash. It still will be the same site. It'll be an HTTPS site. It'll be your vCenter appliance. It could be the IP address and then / vSphere client, and you'll be directed to it. You can add Windows authentication, so you can use Active Directory in order to log in. Like I said, there is a HTML5 base that doesn't depend on any Adobe, but it does use Java. So it'll be that, HTTPS, your IP address / UI if you want to get to the hypervisor. ESXi is the hypervisor that sits below. vSphere client is what will allow you to manage the clients themselves. And again, we'll cover this as we get into the chapters. This is important, what each file is. Because a virtual machine in itself is kind of the abstract, that's the whole. You have all of that stored in a folder for easy convenience and having everything together. And then what each file is. This is important to know. So for example, the configuration file of the virtual machine, what has the name, which has the descriptions, which has what network card it's using, how big the hard drive is and where it is, all that kind of stuff. That is the .vmx file. If there is a swap file, you will see it as a VSWP file. The BIOS is NVRAM. The disk is VMDK. There are a number of VMDK types, but they are all, anything that is a disk file will be VMDK. So for example, a flat file will have VM, the name of it, -flat, and then .vmdk. Any snapshots will have a different format. There'll be VMSDs or SNs, or the memory is vmem. If the VM gets suspended, it goes to a different file. Even though this is completely virtual, it does have its limitations. Some of the limitations are shown here. For example, you can have up to 2 IDE controllers. If we're talking about an older OS, we can have up to 3 parallel ports, 32 serial ports. We can have 1 USB controller with 20 devices attached to it. We can have a floppy with 2 devices, 1 floppy controller with 2 floppy drives. We can have up to 4 SCSI adapters with 64 devices per, 1 mouse, 1 keyboard, up to 128 CPUs, 6 terabytes of RAM, 10 network cards, and 1 hardware 3D video card. Now, obviously, if your physical hardware doesn't have 6 terabytes of RAM, you can't assign 6 terabytes of RAM, but these are the limits for a virtual machine. Hardware versions are a good thing to know. It is necessary to know what hardware version ties with what. So for example, anything that you see that's hardware version 10 comes from ESXi 5.5. Anything 6.0 is 11, 6.5, 13, and so on. That comes into play when you're working with different virtual machines from different people and they were created on different systems, or you need to make a virtual machine and you have the latest version of ESXi. So you have 6.7, but the system that you're going to import this VM to is running 6.0. Well, you need to make sure that your hardware version matches the one that you're building for. You have a variety of choices when it comes to storage. You can go from bus all the way to a virtual NVMe. This is all in order for you to be able to simulate whatever physical hardware you need for the OS. Whenever you see thick versus thin provision, thick provision means if we're making a drive of 20 gigabytes, we're going to actually create a file and it's going to take 20 gigabytes. Rather than a thin provision disk that says, oh, we're 20 gigabytes big, but it's really only using 2 gigabytes because that's how much data it actually has. A thin provision disk will grow, whereas a thick provision won't. There are 2 sub options between thick provision. You have the eager 0 and lazy 0. In eager 0, every block is pre-filled with a 0. In lazy 0, every block has a 0 when data is written to that block. Here's thin provision, like I said. Just because you make for example, here you make a 40 gigabyte disk, but you're not using the full 40 gigabytes, it won't actually use the full. It knows the maximum, but the file itself is only as big as the amount of data it stores. Here's a chart kind of showing you all the options that you have and kind of side-by-side comparison. Virtual networks, the way that the virtual machines will be able to talk to one another. You can define the type of adapter that it'll use, the port group that it'll be connected to, the state, whether on or off, and whether you want the network card to be turned on the moment the VM turns on. So basically think of the last option is the cable physically connected to the NIC card or is it disconnected from the NIC card? There are 3 main network adapter types. You got the flexible, the E1000, and the VMX Net3. VMX Net 3 tends to be the one that is always recommended because it works with VMware tools and is native to the VMware world. The E1000s work on some operating systems, not all. You do have a few more options like SR-IOV pass-through, which again, it can only support a few OSs. The direct path using physical PCI network functions, and PVR DMA, which provides an RDMA-like interface for any vSphere guests. Now that we covered the main items that are needed to operate a virtual machine, we have a few miscellaneous items like CD DVD drive. Whenever you want to install an operating system, you need an ISO file in order to get the process started. USB 3.0 is supported in virtual machines. Floppy drives are still around, just in case you need to run something that requires a floppy. You also have generic SCSI, and you have virtual GPU cards. These are all available to your virtual machine. The console, where you're going to spend most of your time, has a number of items, for example, where you see what's happening with the client, where you can interact with it, where you can reach the console in order to get a GUI of the VM, along with resetting, turning it off, snapshots, all that kind of stuff is all done through the web client. Any questions before I move on to this next portion? Okay. So here we go. ESXi is the hypervisor. This is what you install into the physical system. It is freely available, so you can install it on any hardware that supports it. It is very small. It does not use a lot of CPU. It doesn't use a lot of memory or a hard drive space because it is a very shrunken down Linux OS that only does a few things because you're supposed to be able to manage it from things like vCenter or through the web. So in order for all these, for all this to function, you need to have that hypervisor installed, which is the VM kernel. That is what will provide you the availability to do everything from running vCenter to controlling what's happening to managing the resources. That is the fundamental base that you need. It is what stands between the physical hardware and everything else that we'll talk about. Installing it is pretty straightforward, especially because it doesn't have a lot of options to maneuver. If you are ever looking at ESXi from a console, like you attach a keyboard, mouse, and monitor to, you're not going to get much. For example, you'll be greeted with this, where you would hit F2 to log in, and then you have a very few items here to change, like the password, the management network that controls the system, the keyboard, and the system logs. All the more complex stuff is done through vCenter, not in this console. For example, here you can enable or disable SSH, and then you would have to use another system to SSH into the box. It comes with a firewall that automatically blocks any incoming and outgoing traffic, except for whatever is approved. That, of course, you can adjust when you log in to the web client. Things like NTP and DCUI can be turned on and off as needed. If there are any local users created, they'll be managed through the command ESXCLI. But usually, you have your root account that you should install a secure password to, and then manage it through vCenter. You should have your hypervisors connected to an NTP server in order to have an accurate time, so that your graphs are accurate, so that everything is synchronized, so your logs are all matched. It is very important to have your hosts with the proper time. You can, something in 6.7, do a quick boot where we don't really restart the entire system. Because if you've ever worked with a server, you know it takes quite a number of minutes for the physical box to start up again. There is an option in 6.7 where the system will reboot, but it will really reinitialize the operating system and not so much the physical hardware. The demo you'll see as you work in the labs. Any questions? That is actually all of module 2. Like I said, these chapters aren't huge. They're not too crazy, but I did split them up so that we can cover a little bit by bit as we go. But again, if you feel like you have the time to go further ahead, you are more than welcome to go ahead. And I will be recording 2 chapters every week until week 7. And then week 8, there won't be a live stream in order to allow everybody to catch up. And then we'll pick up again week 9 with 2 chapters all the way to the end.